Hello guys, welcome back to a new video. So today let me change the view first. Okay. Today we are going to solve this problem, top k frequent elements. Yesterday we solved this problem. If you haven't watched that video, I have created a playlist. You can go and watch all these videos sequentially or in any order. Yeah. So also if you haven't subscribed yet, consider subscribing. So let's move to the question. So we have given an array of nums and an integer k, return the k most frequent element. You may return in any order. So that's basically the question is we will be given these nums and the k value. So we have to return the k most frequent element inside this. So these will be the constraints, and this is a special thing here. K is in the range of 1 to number of unique elements in the array. We have to build our solution around that. This will help us in building our solution. Yeah, I also guarantee that the answer is unique. Yeah, so first approach will going to be, so we will calculate the frequency in a frequency map of each number. Like the map contains a key 1 and which will have a frequency 3. Similarly, key equals to 2 and the frequency corresponding will be 2, and so forth. So after that, what we can do is we can have a priority queue, or in terms of data structure it will be under the hood heaps. What they will do is they will maintain the maximum heap here. uh, so what we will do, we will so under the hood it will be maximum. So we will use priority queue. Under the hood it will be a heap. So we will maintain a heap where we will have these values in order. So let's see how we are going to build this. So let me just write the code for this. We will maintain those top k elements there, and we will just rest we will pop out from the priority queue. So let's see what how we are going to write this. So basically first we will have the unordered map. Let me write, yes, int that will be called freq, that will have the frequency. Then we will run the for loop and pick out num in this nums array, and we will increase the frequency of corresponding number or element present in this nums array. Then what we can do is we will have a priority priority queue. So the element inside will be like this, a pair of int and int, and here we have to write the vector of pair of int and int, and then we have to call this function inside this. And yes, so why we are writing this, so let's just Google search something. Let's search priority queue in C++. Just see this. I just want to show you this, why we are writing that. That's a language specific thing. There might be different way to implement it in different language. In C++ we implement the heap like this. So basically, as you can see, we are pushing 10, 20, 30 here, and it is in as you can see, the top element we are picking out is the max. So this is how we implement a max heap. But if we want to implement a min heap, we like this in this way. So that's what I want to show you. Now here you can see the minimum element come out first. So yeah, I guess they are popping out one by one here. Yeah, show pq, yes. So that's why we are going to implement this. So here priority queue, this is our element type, which is a pair of int and int, and in this vector we also add our type. Similarly, in greater function, we also write our type. So just how this will be let me write a min heap. Now what we can do is we can run it for, let's say, yeah, while, like, we have to put this in all the elements. So for let's say element in this freak, we will do is pq dot push. So this element will be a key value. So let me write key value here, key val, and we will push it the val against the key, because we want to sort based on the frequency. So yeah, so that's why we just reverse the order in the pair. And if, or let's say while pq dot size is greater than k, we will pop out the element. Now after this we have all the values inserted, and what we are going to do is, and it will maintain only k values here, rest it will pop out. So what we have to do is just we have to just get the same key and, well, no, what we have to do is we have to just so the return type of this is a vector of int, so we have to create our return variable. Let's say answer, we are going to return this, and we have to populate our answer. So while our pq is not empty, so inside only answer will be there. So inside this pq or priority queue or the min heap, only the key elements will be there, because we have maintained it here using this while loop. So now we have to only pick out these elements one by one, and I have to push inside this. So answer dot push back, we have to return the pq dot top dot second and pq dot pop. So let's see if it works. Yeah, so it is an empty because we are not pushing, we are pushing it here. And let me check it once again. So we are having a freak, then we are just, and then for key value inside this freak map, we are pushing all this value inside this while maintaining the size of the pq as k, and we are popping out while the k is greater. Okay, then what we are doing is we are creating an answer dot that second. Let's write this way, auto data equals to this pq dot top and then data dot second. Why is it is coming out to be empty? There might be some problem. We have to see. Let me check once again what we are missing while pq. So yes, this should be empty. Yes, that's the problem here. Yes, so let me submit it. Yeah, so this is working. Let me check, let us check the time complexity of this. So here there is one for loop. I guess this is the first for loop, which is n. Let's say n is the number of elements inside this nums array, so it will run for n. Then this for loop, so this for loop will run for like maximum it will run for n, since the frequency can be at most maximum the element inside this map can at most n. So that's why this and this is going to be like at most. So it we are always like what you can say, we are always maintaining the k value inside this. So this is always going to be so the insertion here is always going to be k log n or log k, sorry. So insertion is going to be always log k, because at most this pq will have k elements and the insertion is log of k or log of whatever the values inside present. So yeah, and this while loop only never runs for one time, I guess, because we are just every time we are pushing it, we are just popping out the first element if it crosses k values. Yeah, so it makes is going to be run for one time. So yeah, and so overall time complexity will be, so this n plus this n log k. So what, and all this while loop all going to be run for k, because there are always k element present in the pq after this for loop. So the overall time complexity will be, let me write, time complexity equals to, if you can see, complexity will be n plus n log k plus k. So whatever be the maximum value of this will be the time velocity. So at max it will going to be have this n log k. Now there is something written in this question, is that can we do better than n log n? So this is better n log k. Now we can do better than this also. So there is a solution using bucket sort. Let us see how the solution works. Let me write the code here. So we, for that we need at least these things. Now let's create a vector of vector. So we need to create the buckets. So let's call it buckets, and the size will going to be whatever the frequency size or whatever the unique values will present inside this. So unique values are like, number of unique values are 1, 2 and 3. So this will be stored in the keys in the frequency. So I guess you understand what I'm trying to say. So frequency dot size plus 1, since the values start from 1. So let me just have the exact value. Now what we can do is we can just push the run the for loop over this auto element inside this free, and we can just push the element inside this bucket corresponding the bucket's value. So element dot first, here frequency is storing the, yes, so we have to do the reverse. We have to store the the sample set of the frequency. Sample set, what I mean is, so let me write this for you, this frequency here. Just try to focus on this, what I am trying to write here. So after this frequency, our map will look like this. So here let me write this as well. So 1 will have 3, 2 will have 2 and 3 will have 1. So now these are the values sample sets 3 to 1. So we the buckets will be these values. The bucket will hold these values. So what we can do is we can just like the value of the bucket second dot push back element dot first. So this will be pushed against these three. One will be pushed to 3. So all these are unique. So currently each one have only one value. And then since now what we have to do is we have to pick out each bucket from these buckets. So let me write here. So that the buckets will look like this. So we have a bucket of size this 3, 1 2 3, and the first bucket like 3. So here 3 will we are storing this. So the like here this is 3. Let me write 0. So I'm writing the indexes of this bucket. So yeah, I guess this is good. So the third bucket here will have this one. So this, oh, what happened? So this will have this one, this 2 will have this 2. So let me write one first. This 2 will have this 2, and this one will have this 3, because the frequency of 1 is 3, and no other number having the frequency as 3. So this all these have like only one element inside these buckets. So that's why it's looking like this. So what we have to do is we have to pick out for bucket sorting. We have to pick out every bucket from the buckets, and then inside this bucket we have to pick out the element, and then we have to push it inside our answer vector. So that will be like this. This I y. So if answer dot size becomes, so only we have to push k values, top k values. So if answer dot size is greater than, then we will just return our answer. And also we have to return our answer. So that case I guess will never come, but yeah. And also before doing this operation we have to reverse the buckets, because we want top k values. So that's why I just reverse this. So there is a function reverse that will reverse these buckets. Yep, I think this would work. Let me just check. Yeah, so this should be buckets dot begin. Spelling of begin is wrong. Yeah, so it's saying output is this, and we need only this out. So we are pushing extra values here. If greater than equals to, yeah, let me just recheck this. So we are picking out this, and we have to only return k values, and the size will have yeah. So let's try to submit this. Yeah, I guess there is a problem here. Let me recheck this. Dot element dot first reverse bucket push this element. Yeah, so I guess this size should not be the equals to frequency's size. It should be all the numbers in present, the size of basically size of this nums array. So that's what we are doing wrong. Let me just change this freq size to this and see if it works or now or not. Yeah, now it's working. Let's test for this. Yeah, so now it's working. So let me just reiterate from the very top. So what we are doing, we are storing all these frequencies in this map like this, as you can see. Then what we are creating a bucket of size number of elements inside this given array. That will be all the possibility because we have like written here. Let me show you this. That will be the possibilities. So then what we are doing is, so this is the sort of buckets, and then what we are doing is we are reversing it because we want top k elements, and then what we are picking out the bucket and element and push it all the elements that are required. So that is we need only k top element, so that's why we like only having k elements and we are returning if it satisfies this. So now let's calculate the time complexity for this. Let me check if it is recording or not. Yes, it is recording. So the time complexity for this is n, which we already discussed, and for this we are iterating our frequency, so it will be most n, and rest we are not doing any stuff here. Also this is two for loops, so the number of buckets is, we need to know that it is n, and the elements can goes to, so that will always be a constant value because this is not going to be as comparable to n. So let's count as O1 because we are just having these buckets, so that's why it will not be comparable to n, so that's why it is O of n. And yeah, so this for loop is overall n, so the time complexity will now become n plus n. So that's the overall time complexity for this. So thanks for watching. If you like the video, please hit like and also consider subscribing, and I will, so let me just check this. We solved this today and tomorrow we are going to solve this, so I will see you in the next video.